This is Note Taking Guide 10.5 for Math 2. We're going to talk about similar solids today. So similar solids are solids that have a common ratio, a ratio that tells you how to multiply the small one by a scale factor to get to the bigger one. So a number that will multiply the height by the height, the side by the side, all of the things have to have that same number that we would multiply by in order to get to the other solid. So in order to tell whether or not they're similar, we're going to look for the scale factor. So I'm going to compare similar parts. So I'm going to compare the height of the small one to the height of the big one. And I'm going to find that scale factor. I'm just going to let my calculator simplify that for me. And then I'm going to compare other similar sides. So the 16.5 is the same side that is associated with the other pyramid, which would be equal to 22. And then I'm going to compare that last side together, which is 18 over 24. And what I need to do is just punch those fractions in my calculator and see if they reduce to the same fraction. So when I put 21 over 24 on my calculator, over 28 in my calculator, I get 3/4. Then I'm going to do 16.5 over 22 on my calculator. And when I do that, I also get 3/4. And then 18 over 24 on my calculator. When I do that, I also get 3/4. This would be considered the scale factor because it's the same number that I multiply one number by to get to the other number. And this would be, because the scale factor is the same on all parts of this pyramid, we know that our shapes are similar. All right, so are these figures similar? If yes, state the scale factor. So again, we're just going to compare parts. We're going to go 14 over 10 because that's the radius of the big one to the radius of the little one. And we're going to see if that equals to 42 over 35 because those would be the sides that are similar, the height of the cylinder here. So 14 over 10 on our calculators would be 7 over 5. And then we're going to see if 42 over 35 will give us that similar fraction. And when I do that on my calculator, it gives me 6 over 5. Because I did not get the same number of comparison there, my answer would be no, these shapes are not similar. All right, so let's use that information now then to set up a proportion that we can cross multiply and solve. So I'm looking over here for the slant height of the cone. I know this slant height, so I can go 13 over L. And then I can go 5 over 7, remembering to start with the same cone that I started with the first time. To cross multiply, when I go top to bottom there, I have 13 times 7, which is 91. And then the other direction, I would have 5 times L. I'm going to divide both sides by 5 in order to solve that. And when I do, I get my slant height as 18.2. And that would be yards because my measurement is in yards. Okay, again, we're told here that we have a similar set of pyramids here. And so it says, in this similar set of pyramids, use the information to find the surface area of Pyramid A. Now, if you remember at the top of your note-taking guide, it has a little hint there that talks about how surface area, if you're going from the scale factor to a surface area, you're going to have to square that scale factor. And if you're going to use that scale factor to get to volume, you're going to have to cube that scale factor. So here when I'm looking at this, let's just start with similar parts. I have here 6 and 10 that I can compare. So I'm going to go 6 over 10 equals, and then I'm going to talk about surface areas. I know the big one is 600. I'm looking for the small one. I'm just going to put S for surface area. But again, remembering our rule that's at the top of this note-taking guide, it says if we're going to use a scale factor, we would have to square it to get to the surface area. So we're going to square that, so we're dealing with surface area. So if I do 6 over 10 on my calculator and I square that, what do I get when I do that? I get 9 over 25. So I'd have 9 over 25 equals S over 600. And I would cross multiply. So 9 times 600 is 5,400. And then 25S the other direction. I'd have to divide both sides by 25 to solve for this. So 5,400 divided by 25. And when I do that, I get my surface area is 216. It's an area, so it's going to be feet squared. All right, this next one right here says a scale factor between two similar figures is given. The surface area and the volume of the smaller figure is given. Find the surface area and the volume of the larger figure. So this is the smaller figure. So my scale factor is smaller of 1 to bigger of 2 using this right here. And then I'm going to go 90 over the surface area that I'm looking for. Then again, remembering that we're going to surface area here, we're going to square that because to go to surface area, we have to square our scale factor. When I square this, I get 1 over 4, and then I'd have 90 over S still. I'm going to cross multiply and solve. So this direction I get 5, and this direction I get That's funny. I thought that was a 5. I'm like, something went wrong here. You guys, that's not a 5. Sorry about that. This is my S. So coming back and just looking at this direction, I get 1S. And this direction, I get 360. So my surface area is 360 yards squared. I have to do the same thing to solve for my volume. So I'm going to set it up the same way. I'm going to do 1/2, but I'm going to have to cube that because I'm going to volume this time, equals 216 over the volume that I'm looking for. Again, do the math over here. You'd get 1/8 equals 216 over the volume. So cross multiplying this way, I get volume, and cross multiplying the other way, I'd have 216 times 8, which is 1,728 yards cubed. Again, because volume, I'd have to take that scale factor and cube it. All right, one more problem here on this page. It says two perfume bottles are mathematically similar in shape. The one smaller is 6 centimeters high and holds 30 milliliters. The one that's larger is 9 centimeters high. What volume of perfume will it hold? So let's remember, we're small to big, and we're talking about volume, which means I'm going to have to cube it. So 6 to 9 and then cube it is going to be equal to the volume of the small one over the volume of the big one, but I don't know the big one yet. So on my calculator, I'm going to do 6/9 and I'm going to cube it. When I do that, I get 8 over 27. So this changes to 8 over 27 equals 30 over V, and then I'm going to cross multiply and solve. So this direction I get 8V, and the other direction I have 27 times 30, which is 810. Divide both sides by 810. Or I should say divide 810 by 8. I'm sorry, I got to get the V by itself here. So divide 8 to the other side. So you'd have 810 divided by 8. And when you do that, you get 101.25. We're talking about a volume here, so we're centimeters cubed. Good luck on your homework.